So, day 12 of Advent of Code is another one of these problems that I think would be interesting to explore using a GUI. So, I've set it up so that it's ready to go. I'm not going to make you go through the whole line, new, quill, blah, blah, blah. I've got it all set up so that we can start. And this time, I want to do it in high discipline mode, right? Lots of tests. Try to avoid the rat holes. Let's see. Let's see if we can do this in a way that doesn't send us down crazy, debugging, nasty rat holes. So here's our setup. I've got the standard kind of quill beginning. So we've got the setup function and the update state function, which doesn't do anything at the moment, and the draw state function, which just puts up a nice sky blue background, and the normal sketch, which creates a 1,000 by 1,000 canvas. Okay, and I've got a namespace here, a closure namespace for all of our business rules. Right, this is going to be the data namespace. So we'll keep the business rules separate from the GUI. Right, it's always a good idea. And I've got the spec file, the test file, which will be testing data. Probably not anything in the GUI. We will keep the GUI as simple as possible. Okay, let's take a look at the problem to be solved. Now, the problem here is a kind of navigation problem. They are going to give us a set of instructions. The instructions look like this. And what does that mean? F means go forward 10 spaces. F10, go forward 10 spaces. What direction is forward? It's the direction we are facing. Then there's another command here, go north 3 spaces. Well, that does not mean go the direction you're facing, nor does it mean to turn the vessel and then go north. It means go north but maintain your current heading. Heading is the direction that the ship faces. So then we go forward again, 7, and then we turn right 90 degrees. Now, I have looked through the input data, and in fact, I'll show you that. Let's take a look at the input data, and you can see that there's L's, that's left 180, and right 180, and left 90, and right 90, and I believe, although the requirements do not say this, I believe that all of the turns are multiples of 90 degrees. I'm going to make that assumption for the moment, because that makes things an awful lot simpler. So we'll see. That assumption may actually be incorrect. Both of those assumptions may be incorrect. It might not make things simpler. I don't know, but I'm assuming. I'm assuming. Now, I saw this on an old Odd Couple once. Felix, when he was in a courtroom, drew this on a piece of paper and said to the judge, you know, Judge, when you assume, you make an ass out of you and me. And the judge laughed and said, I like that. All right, so those are the assumptions I'm going to make, and maybe I'm making an ass out of you and me, or at least myself. All right. What is the purpose of our navigation? You can kind of infer all the commands, north, south, east, west, left, right, and forward. Those are the only commands we've got. And in the end, at the end of these instructions, the ship's Manhattan distance, what kind of goofball name is that, which is the sum of the absolute values of its east and west position and its north and south position. All right, so you just take the absolute values of the coordinates and you add them together and you get a 25. Now, I don't know why anybody thought that was an interesting metric, but that's what we're supposed to return. Okay, lovely. All right, there's something I want to do before we begin anything else, and that is when I am drawing, I want the background to be blue. I've already got that. And I want to do a translate to the midpoint. Now I got 1,000 by 1,000 grid. Yeah, translate. I got 1,000 by 1,000 grid. So I'm going to put 0, 0 at 500, 500, which is not exactly in the middle, but probably close enough for government work. If I run this, you will see that I get a nice 1,000 by 1,000 canvas in a beautiful cerulean blue. Okay, all right. Good enough. All right. There's a few things that we need to understand before we begin. What is the world that we are going to be drawing? And the world that we are going to be drawing is going to be a map, and it has a direction. This is let's call it the heading. This is the direction that the ship is facing. And at the moment, I'm going to assume that I can use the 4 cardinal compass directions, because I believe every rotation is a rotation of 90 degrees. So I'm going to say east. Now, maybe you're thinking I should use a compass direction. Maybe you're thinking I should use a number of degrees. Like maybe I should make east 90, because that would be the pilot's version of what east is. Well, I'm gonna keep it this way for the moment. We'll see. That's an assumption. Yeah, eastward. Didn't tell us that. Yikes. All right. So the heading of the ship is east. The position of the ship. So the position of the ship. Position. Might as well name it. Is going to be 0, 0. So we're going to put it at the origin. Position, yes, I got that spelled right. And I'm going to create a list of past positions. I'll call it the trail. And that'll be an empty list. Now, again, I'm making an assumption that I'm going to need this. I have this idea that I'm going to draw lines for every motion of the ship. We'll see. So that's going to be our world. Our world is going to look like that. Okay. When we update the state, at the moment we're just going to return the state. Although it would not be a bad idea here to destructure it. So let's destructure it. I think that's how we do that. I think that is the destructuring. And let's just make sure that we can do that. Nice. Bring it all in. Yes. Okay. Good. And then for the moment, we're just going to return that and ignore the destructuring. But at some later time, we will want those destructured variables. And now to draw the state, well, just for grins right now, I want to say Q / ellipse, and I want to draw it at that position. Now, I don't know about the magnification yet. So I'm just going to draw it at those coordinates, and then later on we'll figure out, well, maybe we should multiply that by 10 or maybe 5 or something like that. Ellipse, and this is going to be, okay, let's destructure the state. So I think I can just take this again and put that here. And generally, we do not need the as state. Again, that's an assumption that will probably prove incorrect, but for the moment, we're going to let it stay that way. And we're going to take the position, and we're going to say first position and second position. That'll be the coordinates, and then the size will be 5 and 5. And we might as well fill this. So let's fill it, Q/fill with black, just so that we can see it. And if I have done this correctly, there should now be a black dot in the middle of that blue field. Let's see. Ah, yes, there is a black dot in the middle of the blue field. That's what I wanted. Okay. Now, I want to be able to move the ship north, south, east, and west. Okay. So let's describe. Wrong one. I got to go over to my spec. And we will break out of here. Lovely. Describe moving the ship. Okay. It should go north. Okay. Now we want the world. Let the world be we probably don't need this, but I'm going to be complete about it. Heading east, position, let's say 0, 0. And I'm not even going to mess with the, here the trail is nothing. Okay, that will be our world. It should equal, so let's not put the it in there yet. Let's do this. Let's take this let, and we will take this let up above the it, because this is going to be the initial data for a series of tests. Okay, that's a good idea. And we're going to need a closing paren. Good. And let's see if all the indents line up. They do. All right. Now we're going to say, let world be move ship east by 10. Okay. If we move the ship east by 10, and now we will destructure this. Let us not destructure it. Let us say position is position world. And should equal position, now east. Well, what do we think of as east? Let us assume that east is the positive x direction. So that should then be 10, 0. That should be how we go north. We should go north. All right, Bob. North. Where were my pair programmers? You should have been shouting at the screen. North. I'm hoping to do this in a disciplined way, but a pair programmer would sure help me right now. Okay, north will be in the positive y direction, so that should be 0, 10. I believe that is correct. Now our data namespace now needs a defin of move ship, and this will be direction and distance, and we need the world. We need the world. Should the world be the first argument or the last argument? Let us make it the first argument. All right. And, well, this should fail horribly. Which it does. Fails horribly. Cannot take a value of a macro, which, of course, I did not put the parenthesis there. Pair programmers, where were you? All right, let's see what this did. Ah, excellent. Yes, expected a nil, but got 0, 10. Well, I can make that pass, of course, by returning 0, 10, which I believe will now pass. Oh, it did not pass. Why did it not pass? Let's see, position world. Ooh, well, I don't want to do that, do I? No, no, no. I want to say assoc world position. Yes. Okay. And for that, I need a closing paren, and that should pass. All right. We got a passing test. Now let's do another direction. It should go east. Let us do east. Okay. Let the world. We're going to start there again, and we're going to repeat. Let's just repeat this whole thing here. Yes, I could put it in a function. You're right. Maybe I will. Okay, this is going to be east. We're going to go east 10. We're going to get the position of the world. It should equal, all right, east is positive x direction, 0 y direction. So this should fail. So now I actually have to do something worthwhile. What could that be? Well, let's say this. Let the vector, not vector, let's say let the motion let the motion be cond p equals direction colon east is going to be in the x direction but not in the y direction. Colon west will be in the negative x direction but not in the y direction. Colon north will be not in the x direction but in the positive y direction. And colon south will be in the not in the x direction but in the negative y direction. And now, by the way, on the screen, north is going to be down. We'll tolerate that. I don't want to mess around with negating things. I got into a lot of trouble with that yesterday, so I'm going to leave it this way. And at some time in the future, if it bothers us too much, I may flip it. I think I know how to flip it. Like I can just change those vectors there. But okay, all right. Let's leave that as it is. Now we want to say that the position is the position of the world. All right. I could have destructured this. Not sure that's necessary. Then I want to say that the new position is equal to, and let us now destructure this to say x and y, and let us destructure that to be dx and dy. That's an interesting way of doing it. All right. The new position is going to be a vector, which is the addition of x and the distance times dx. And the sum of y and the distance times dy. Now, I believe that is correct. And now, that is the new position. I want to associate the world's position with new position. So that will change the world so that it has the new position. Let us see if this worked. Something went wrong. Unable to resolve symbol new position. Yes, that's because my parenthesis here was incorrect. We will now put the correct parenthesis by slurping that in, and we will do the check, and oh heavens, look, it goes east. All right, that's good. And you will notice that it did not check go north because it did not perceive a change there, but we could run the entire suite of tests to demonstrate that north was not affected. Well, it says should go east. And, all right, fine. Why isn't it telling me about north? Let us change that so that we see that that is in fact getting executed. It's not getting executed. So why not? Oh my goodness! I am. Dear pair programmers, where are you? Where are you, pair programmers? Oh my goodness. Yeah, well, rat holes. What can you do, You just make a dumb mistake. All right. Let us see now. Okay, that it closes. That it closes. Lovely. This let goes around all of those its. Okay. Should equal position 110, should equal position 10-0. And it still looks like it's saying that, well, let's just be sure about this. Let's run the entire test to be sure. It should show both of them. It does not. I am going to kill this. And I'm going to rerun auto. Because I have a suspicion that the closure environment got corrupted. This sometimes happens. No, that was not the problem. Okay. This it closes there. This it closes there. It is... There seems to be a difference. No, there's no difference. Okay. Let's do this. I am going to take this let out of here, put it outside of the describe, that looks correct, that looks correct. There was something about that let that corrupted the way that the test framework was working. And I do seem to recall that that's a symptom of Speckle J. And in fact, there is another gesture inside of Speckle J for doing setups, which I probably should have been using here. Okay. All right, let us do the other directions. And for the other directions, let's create a function here because this is relatively ugly. So we're going to make a little utility function. And we're going to call it should move ship. Okay. And it's going to have a world, a direction, a distance, and a final position. All right, that will be our function. The function should look something like this. Except this will be the direction. This will be the distance. And this will be the final position. Good. Okay, so now we want to replace this with should move ship, world, north, 10, and 0, 10, like so. And we should no longer need this. And it still passes. All right. So now we should be able to take this and put it here. And this should be colon east. And this should be, what was it? 10, 0. And somewhere in there I lost a parenthesis. I'm not sure exactly where. But that should still work. It does. All right. Lovely. Now I don't think I need to have separate its. You know, they're not really hurting. Let's just keep it. So let's do the others. Yeah, okay, I screwed up my parentheses again, maybe. Maybe I did. Yeah, because that should have a closed parenthesis there. And this should have a closed parenthesis there. And this should have a closed parenthesis here. And I don't need most of these. Okay, and that one matches the describe, and this one matches the let. All right, and this is east, so this is going to be south. And that should be 0 minus 10. And this one should be and northeast, south, and west. And that one should be minus 10, 0. And I think I screwed up my direction because the west one expected 10, 0. Oh, well, I did not change that to west. Ah, they all work. I can now move the ship using cardinal directions. Okay, let's do that. This is nice. Most of this is pretty. Good. Yep, everything seems nice. I would like to move the ship forward. Interesting. Now, that's kind of an interesting possibility. Should I have move ship with a forward direction? Kind of think not, actually. I think I should have a move ship forward. So let's do that. Let's describe moving ship forward. Okay. I don't need a new describe for that. Let's just add it as a new it, right? Yeah, okay. It should go forward. Okay. Now, for this one, we're going to go back and get this little snippet of code right there. And we're going to paste it in. We cannot use should move ship here. But we can do this. And this is going to be move ship. Let's call this forward ship. We do not need a direction, but we do need a distance. And the final position is going to be, well, we don't know, but the initial position of the ship, we can see here, is east. And by the way, that is the initial position in the rules. So, okay, this should be the same as going east. And the distance is going to be 10. All right, should equal position. And this will be east. So that would be positive x. Yes, positive x. Now that's forward ship. Good. And let us now write this function. Define forward ship, which takes the world and a distance. And it's simply going to return move ship world, direction of world, heading of world. Pair programmers. Distance. I believe that's all there is to it, guys. As in, that one works. There's no need to test that one further as far as I know. Okay. Now come the rotations. The rotations are very interesting. Let's describe rotating the ship. Now this one's going to be interesting. It seems to me that the input data always has a positive number, and it's either a 90 or a 180. I don't think there's anything else. It's 90 or 180. I mean, maybe there's a surprise in there. I haven't found the surprise. We'll look for it a little bit later, but that is my assumption. No, forward 30. I thought maybe that was degrees, but it's not. So I believe it's going to be 90 or 180, and that's all. Okay. So we're going to rotate the ship. And there's two directions, left or right. Okay. It should rotate right 90. Okay. Alrighty. I think we're going to do, well, I'm just going to type it. Let world be rotate ship right 90. Yeah. Right 90. How about that? I'm putting a lot of emphasis on this assumption of mine. And you know what? Part 2 is probably going to break that. but I'm not doing part 2 at the moment. So we'll just continue this without buying too much trouble for tomorrow. Okay. So, okay. I'm going to look at that world. I'm going to get the heading out of the world now. And now I want to ensure should equal, well, I was east, right? I'm going to rotate 90. That ought to be south. How about that? I believe that is the test. Now, I don't have that function, so let's write the function. Okay. And it should return nothing, so yes, I forgot to put world there. Pair programmers. Okay, good. It fails. It fails for the right reason. I should now be able to say soch world heading south. That should pass. Good. All right, let's continue with what we were doing before, and we'll write our little function here, which is a should rotate ship, or should have heading. How about that? Huh. I don't know if it's worth doing. Here, let's do this. Oh, we'll go ahead and do it. And we'll do it up here. So this is going to be our template. That's what we're going to be wanting. We'll come up here. Should be rotated. Okay. How about should rotate ship? Okay, this is the world. This is the direction we're rotating it. And this is the final direction. This is the heading that it winds up on. Okay, this is the world. This is the direction. And this is the final heading. Let's do this. That's the expected heading, and this is going to be the expected heading here. Lovely. Okay, and we could probably do that. Okay. So now we're going to change this to should rotate ship. Should rotate ship world right 90, and the direction should be south, and that should pass. It does. Okay, that's fine. Let's just do that, and now we're going to take this entire we're going to copy it. Let's see, this will be right 90, right 180, left 90, left 180. Okay. I think that's correct. No, I screwed up a parenthesis. Yeah, okay. Got that. All right, I think I'm missing a parenthesis now. Yes, okay. Well, yeah, that's the let, right? Okay, good. Right 180. Right 180. If we go right 180 from east, we should be going west. Okay. If we go left 90 from east, once again, they all start at east. Left 90, that should be north. And if we go left 180, Pair of programmers. This is going to be left 180. Now those should all fail, which is good. All right, how do we rotate the ship? Well, that's a very interesting question, but I think I know the answer to it because this is all modulus arithmetic, isn't it? So, you're not going to like what I'm going to do here, but perhaps we will be able to refactor it. So, let's begin with this horrible thing that I'm about to do. Current heading, let's call it current compass. I am really going to now shift it 2 degrees. Yes, I know. But there's no downside to doing this because I'm not going to let the degrees leak out of here. But I have a sneaky suspicion that in problem 2, well, no, problem 2 is going to use the same input. So no, I don't think, all right, never mind. I'm still going to use degrees here. Let current compass be cond P equals direction. Okay, east is 90 and south is 180 and west is 270. Every pilot knows, and north is 0. All right. That's what we're going to do. All right. And current rotation is going to be the cond P equals, and oh my goodness, no, this was not correct. That should, pair programmers. This is the heading. Yep, that's the heading. And where do I get the heading from? I get the heading from the world. So let us get the heading from the world. Yes, I could have destructured it. Probably not worth doing for this case. Cond P direction. Now that's different, Ryan. That's different. Because there's 4 possible directions. Okay. Right 90 is going to be 90. Yeah, that's right. And right 180 is going to be 180. Good. And left 90 is going to be minus 90. Yes. And left 180 is going to be minus 180. Oh my God. All right. And the resultant heading is going to be the final compass. The final compass is going to be the modulus of the number, which is the current compass, added to the current rotation. Okay. And the word current is probably not necessary there. Why don't we change that to just plain old compass and rotation? Yeah, that's probably better. And we'll just change that to compass. Yes, I could have used the rename refactoring, but, you know. All right, so the modulus here, if I'm lucky, I can join those. Yes, with what? 360. Now, this sum might be negative, but I'm still modding it with 360. And so let us just go to the REPL for a moment. And we're going to try mod minus 270 of 360. Let's see what it does. Oh, 90. Yeah, okay. And is that correct? Yeah, minus 270 is 90. Yes, so that's fine. Okay. So I think this is right. And now, you're not going to like this, but I'm going to do this anyway, and if you don't like it, I'm sorry. This can all be refactored, and probably will be, but cond P equals final compass 0 is north. 90 is east. 180 is south. And 270 is west. Now, I believe that is going to work. Final compass did not, because that parenthesis right there should be inside. Yes, okay. And we're going to run that, and rotate left 180 failed because, yes, that's not south, that's west. Right. If you rotate 180 from, it doesn't matter whether it's right or left. Yeah, right, okay, fine. And now the tests pass. Okay, we now have all the commands, right? That's all the commands right there. So now let's do this. I want to execute a list of commands. And we know what these commands are, right? So let's do that. Let's execute a list of commands. Okay. I want to execute the list of commands, but I want to do it in the GUI. So, I want to describe execute command. Aha. Okay. Now, let's see. What's the best way to do this? Let's not execute the commands. Let's use a little bit of spying. Let's say it will call move ship. If we execute a command, and the command is going to be north, move north. How about this? Move north. Those aren't the commands that are coming in on the input, are they? Coming in on the input is move north. Okay. move north, and an amount. 10. Okay. And I want to say that the move ship function was called. And we do that this way. We're going to redefine the move ship function to be a stub. Called move ship. This is just the tag that we're going to use later. And let's see, why is the, oh yes, okay. With redefs, yes, okay, that's correct. Now, I think I can do that, and then you say should have invoked move ship. Okay. With and now we need the arguments. And the arguments, yes, okay, I get this. All right, so execute command against the world. World is first. Move north, got it, okay. With world, and the heading will be north, and the distance will be 10. Now, I believe that that is the proper way to do this kind of spying. So let us assume that that is correct. And we're going to define execute command. Good. Which takes the world and the command. And we'll have it do nothing. Although it should return the new world. But we're not going to be caring about that much. And we got a bunch of things that went wrong, so let's see what that was. Command will call move ship, and variables unbound cannot be cast to Java util current future. In core spec 55, well, that's here. Should have invoked. Oh, there's some other thing I need to do here. Yes. Describe. All right, so yeah, I forgot to do this. This is some magic word that you've got to put in Speckle J for this. Ah, okay. Expected the invocation of move ship with that, but got nothing at all. Okay, let us see if we can make this pass. All right, so I just gave it the move north command. So it seems to me that I can do this. It's another one of these conp things. Okay. And the command I can destructure into the command name and the argument, because I don't know whether that's a distance or not. It might be degrees. All right, so if the command is, and what should I have got? I've got move north. then we should return move ship world north arg. That's what we should call. And let's see if that passes. No pointer exception at data 39, it says. I'm not quite sure that's right. We're going to call move ship. And it should work because I've done the with stubs and the redefs here. So should work. Right? We're calling, move ship, world direction distance. Good. Move ship, world direction distance. Yep. Okay. I put a colon there. That should not be a colon. And that worked. Lovely. Okay. I have done this before, but every time I do it, it's like, oh, yeah, how the heck do you do that? It is not the most convenient way of doing a spy. On the other hand, once you get used to it, I suppose it's fine. All right, having done that, I should now be able to do this over and over again. Okay. It is calling move ship correctly. Fine. Execute command. Yep, it is calling it correctly. Let's try a different one. It will call move ship going north. Will it call move ship going south? How am I going to do this realistically? Well, I could do this. And it will call move ship to the north. It will call move ship to the south. And now this should be move south. And this should be south. That should fail. No matching clause move south. This is move ship. No. This is move ship south. Yes. No matching clause. Yes. Okay, fine. And that should now pass. It does. Okay. Well, the others are kind of obvious. And you could argue with me and say, Bob, you shouldn't have these move north, move south, move east commands. You should have broken it up so that it was, move and then an argument for the direction. But I'm trying to mimic the input commands as closely as possible. So those are those commands. And I suppose I could duplicate all of these. I don't know that that's really worthwhile. Let's see if that, it's just a kind of pain in the butt to reproduce all of those, but let's go ahead and do it anyway. Because there's only a few of them. Alright, let's bring them all back in. Yep, okay. It will call move ship to the north, to the south. This should be east. And this should be west. I know this is a little bit worthless, but you know, what can you do? Did I do that wrong? Yes, that's east. And this is going to be west. And this is going to be west. And let's just make sure all of that works. It does. Okay, so I am definitely translating it properly. There are other commands, like forward. So let's take this, copy it. Okay, it will call forward ship properly. This is going to be move forward. The stub we are after is forward ship. With the world and the direction, this should fail. It did not fail. Why didn't it fail? We'll call move ship to the north and the south, but we are not seeing all the others, so there's some bizarreness here. Let's just do them all. All right, so we're seeing move ship to the north and the south, but we don't see the east. And that's because that is not correct. Yes, okay. And is this one correct? Yes. And is that one correct? Yes. All right. And now is this one correct? Yes. All right. So now let's see if we see them all. Oh, heavens. Syntax error reading at 86. And that's because we've got too many parentheses. Okay. Try it again. No matching clause move forward. That's over here. So we did get there. That's the way we should call it. Yep, calls forward ship. That's good. And now we've got the rotates. So now it's going to call rotate ship. And that's going to look about the same. So we're going to take this redefs clause here. We're going to stick it in there. This is going to be rotate ship. And we might as well change the tag here. We're going to execute the command right 10. So we can call rotate ship to the right. So we execute the command right 90. Should have executed rotate ship with 90. Okay. Right. Rotate ship. Right. Ooh, that's interesting. 90. So this is interesting because the command is going to come in with right and the number 90, but I want to change the command to be a direction which is right 90. You know, one of these. So I'm going to do this interesting operation here, we are going to call rotate ship with the world, and then this is going to be straightforward. Cond p equals arg 90 is going to be right 90. And 180 is going to be colon right 180. Okay, and should have invoked rotate ship with world and right 90. Now, that worked. We'll call rotate ship to the right. Now let's do to the left. Okay, to the left. All right. A little of that to make it a little nicer. Okay, we're going to go to the left. We are still going to call rotate ship. We're going to execute the command left 90. Lovely. And now we should have invoked rotate ship with world left 90. Okay, now I don't think that's going to work. So let's just do this. This is going to be left. Rotate ship and this is going to be left 90 and left 180. There we go. Huge assumption that these are the only two arguments, but okay. By the way, the thing I'm worried about here is if we have to use real degrees, we're going to start using trig, and when we start using trig, that means floating point numbers, and the coordinates are going to have strange decimal places, and I wanted to avoid that. I don't know if it's going to be possible, but maybe it will. Okay. Well, I think we've got just about everything. I want to do the 180s, so let's do the 180 here. Just make sure that 180 works. The right 90, and this is going to be to the right 180, and this is going to be a 180. And this is going to be a right 180. Yes, that works. Okay, so now let's do this. Yep, okay. Copy that and paste it here. And this is going to be a rotate to the left 90 and rotate to the left 180. And we're going to turn that into a 180, and we're going to say left 180. And that should work. Okay, good, good. These are all the components. This is everything we need. So, last thing we're going to do is parse that input. Now, let's go get the input data for the problem. And they give us a nice little example here. Here's this nice little example, right? Forward 10, north 3, forward 7, right 90, forward 11. Okay, so let's go get this. And we'll put this into our test data. And the test data is going to be just that. Okay. Sounds perfectly reasonable. Now what we want to do is some parsing. So let's check and do some parsing. Parsing is really straightforward. Here's what I'm going to do. Now you might consider this to be a cheat. I think that is the let here. I go all the way up to the let. No, that goes to the describe. So that's the describe. This is the let. Good. Okay, fine. You know, that's the let. It's so damn big. Now we're going to describe the parsing. Okay, we'll parse it. Well, here's what I'm going to do. I'm going to say should equal. Now this is a pretty straightforward input here. So I'm going to just turn that into the commands that I want. And that's going to be forward. Isn't that the name of the command? All right. Let's take a look at our commands. Our commands are move north, move south, move east, move west, move forward. Fine. Whatever. All right. So this is going to be move forward. And we're going to do that. Yes. And we're going to do that. Yes. And move forward. And that's going to be 10. And the next one is going to be move north by 3. Okay? And the next one is going to be move forward by 7. And the next one is going to be rotate right. I think that's the name of the command. No, it's just plain right. Not real consistent, huh? Not real consistent. Okay, well, all right. That's fine, you know. Should have been rotate right, but right. And it's right 90. And the next one is forward, move forward 11. Okay, that's what the result should be. And we're going to say parse input of test data. Okay, that's our test. All right, here, parse there's the input. Let lines be closure.string / split lines of input. Yep. Okay. Map parse lines. And, you know, map V, why not? Okay, well, we need a parse line. Okay, it's going to be a character and then a number. Okay, so conp equals first of line. Okay, makes perfect sense. And let's do this. Let's do this. Instead of that conp, you notice that I like my conps. You know, I like my conps. Don't judge me. I know they're kind of like switch statements, but all right. So let the command. Okay, slow down. Let the command be the first of the line. I believe that will work. Let the argument be. Now I want to take a substring. I don't think the rest works. Well, you know what? Let's check it out. Rest of ABCD. Yeah, no, that's not going to work real well. Although I could do stir of the rest. Apply stir to the rest of A, B, C, D. And that will do kind of what I want. Or I could do a substring. Arg is going to be the substring of the line starting at character 1. And let's do our REPL here. Subs of A, B, C, D starting at 1, and that should be B, C, D. Yes, good. Okay, so all of that should work just fine. And so now we say cond p equals command, and f is going to be, the arg is always a number. So let's say integer slash parse int of the subs of line 1. Yes, okay, so that makes sense. So this is going to be move forward arg. Okay, so north. Move north arg. South. Move south arg. Yeah, okay. East. Move east arg. West. Fortunately, there aren't too many of these. Move west arg. To the right is right arg. And to the left is left arg. Wow, man. Oops, it looked like you tried to add nil to a spec. Oh, heavens. Let's see. How about an it, Bob? It should parse a bunch of commands. And that works. Okay. Now, there's two things I want to do. First of all, I want to know where I wind up. Right. So we should be able to execute all these commands. So if we execute all the commands, so here's our acceptance tests. It solves the first acceptance test, and for that we want to find should equal, what did they say? $25. Right, the Manhattan distance, 25. All right, so we're going to do this. It should equal 25. And what should equal 25? The Manhattan distance. Did I spell Manhattan correctly? Manhattan. Yep. Manhattan. The Manhattan distance of the position of the world of the execute all okay, let's back out of here. Position. All right, fine. That's the should. Got that. Okay, we're going to put a let in here, and that's how we're going to do all this. Let the world begin at a heading of east, and might as well be 0, 0. Yep, okay. Heading east, position 0, 0, and a trail of nothing. Okay, fine. Might as well do it that way. Good. That's what the world is going to be. The world will then become, commands will be the parse input of the test data. Okay. The world will become execute commands, world commands. Okay, good. Position is going to be the position of the world. Oh, lovely. Okay. So what do we need by this? I need execute commands. Execute commands is going to be defin execute commands, which is the world followed by the commands. Thank you for that. And then we say loop over the commands if empty commands, then we're done, and we yes world commands, yes, okay. Then we return the world. Otherwise we recur with the world being the execute command. We execute the first command. Rest commands with the rest of the commands. That's the way we're going to do that. Yep. Okay. That should execute all the commands. And now Manhattan distance. The Manhattan distance is the sum of the math. Is there an abs? No. Math / abs of x, Bob. Wow. Okay. Now, well, that seemed to work. It solved the first acceptance test. So I believe I believe we have solved the problem. So let's solve the problem. Cross your fingers, guys. Okay, and this one is going to be all of this is the same. In fact, I should probably just grab this entire thing. In fact, I should probably just grab this entire thing and put it right in there. And I think I missed a parenthesis. That parenthesis probably doesn't exist anymore. So that goes there. After a while, you do get used to these parentheses, guys. You really do. And let's see. We're going to parse input. Well, this is not going to be test data. This is going to be slurp of input, but roughly the same. All of this is going to be the same, and that's going to be, let's say, 0. And gosh, what's going to happen now? But it's, oh, no matching clause 270. Ooh, 270. There's a 270 in there. There's a 270. Okay. Well, I know what to do about that. So let's go to our spec. Okay. We can rotate 270s. I did not remember that. So let's take this and say, okay, let's add a 270 and rotate right 270. Right 270. That's going to give us a few more issues. And let's do left 270. Okay, and we'll go to our data, and we will have some work to do here. So, for example, these we did correctly, but these we did not. If we go left to 70, it's kind of same as going right 90, isn't it? And if we go right to 70, okay, fine. And down here, we're going to need 270 colon right 270. Boy, you know, I'm not sure this was the right approach, but it does prevent me from having those floating point numbers. But I don't know if that was worth it. Okay, what do we get this time now? No matching clause left. Left 270. Execute command will call rotate ship to the left 270 here. That's a rotate ship. Left 270. Invocation of heading blah blah blah. Left 270. Got heading east. Position 00. Trail nothing left. So that's the world and left. But execute command, left, left is something. Yeah, all right. Pair programmers. Boy. Well, we got 1106. Now, that's interesting. Is that the right answer? Let's go here and see if that's the right answer. 1106. Submit it. That is the right answer. Now, just so that we can say we did it, let's put this on the GUI. Okay, let's put this on the GUI, which should not be very difficult because we've got our core here. And let's see, what should we do? Well, let's say that our setup let's say that our setup also has some commands. And those commands are the parse input of the slurp of input. Okay, those are the commands. Now, when we draw our little ship, let's draw it as a triangle facing our direction. Do I want to do that really? Or do I want to put like a little line out there? Ooh. Yeah, you know, let's just draw the thing walking around. We don't need to draw the heading. Okay, maybe we'll put the heading in a minute. So update. This should be interesting. Okay. There's our commands coming in. Good. Okay. Update state. Well, let the trail be the conj of trail and position. Okay, that's good. So we're going to add to the trail, let command be the first of the commands, let commands be the rest of the commands, let the world be the execute command of the world and the command. Oh, this is just so much fun. Okay. And now we are going to return assoc into the final world the rest of the commands. Yep, okay. And I think I'm missing, yeah, I got the parenthesis wrong there. Okay. And the trail. Yeah, and the trail. Commands and the trail. Good. Okay. So we'll do something with that trail in a minute. We took the command, we took the rest of the commands, we've got all of that. Sure. Now, if I run this, we should see that little circle kind of dodging around, but it might not move not much might happen. Oh, what did I hit? I hit auto. Let's go to run. Let's get rid of the autos here. Let's go to run. And I don't know that we're going to see very much here. Unable to resolve symbol world in this context. As world. There we go. Yeah, okay. Let's try that. Oh, look at it's moving around. Heavens, heavens, heavens. Isn't that nice? Oh. All right. Well, that's what they wanted us to do. It's off the screen. Oh, man. Okay. Well, that's just great. Okay. It finally went crazy and said, hey, look, I can't draw that crap. No matching clause. I don't know what that matching clause problem was. No matching clause via... Okay, that's probably something deep in there. Okay, well... you know... I don't know. Maybe we should make that bigger, huh? So how about 2000? It's not going to fit on the screen, right? So, yeah. Let's watch it again. Absolutely. Oh, it's so big now. Oh, where's it going to go now? Oh, you know what? I didn't change the origin. So hold on. Got to change the origin. So when I draw it, let's translate that to 1000, 1000. Okay, now let's see how it does. Yes, I know. Okay, there it is. Oh, look. Oh, heavens, it's bouncing around. My goodness. Oh, my goodness. Yes. Heavens. Oh, where's it gonna go? Oh, man. Why does this entertain me so much? Yes, okay, so the... Quit that. Let's go back to 500, 500. And let's go back to the 1000, 1000. And let's take all of the coordinates and just divide them by some fixed amount. So, yeah. So, divide the first position by 10. That's probably too much. 5, and we'll divide the second position by 5 as well. Just why not? Now let's watch it go. There, okay, now it probably won't get off the screen because we've multiplied the screen by essentially a factor of 5. Oh, and it wiggles around. Isn't that lovely? Well, like I said, simple pleasures, right? I can't tell you. Oh, there's something funky going on. What do we got? What's the problem here? Some terrible thing is going on. Oh, I think I know what it is, too. No matching clause at 42. Data 42. It's going to be down here. Yeah, it's going to be one of those. No matching clause, but... Oh. Yeah, Bob, you can't do that, can you? I was going to execute commands that didn't exist, right? So I was going to execute right off the end, but I need to stop once the commands are empty. So if the command is empty, I'm not going to execute the world, right? So there's two ways to do this. What happens when you get the first of an empty array, right? First of nothing is nil. All right, so we could do it that way. So if nil command, then just return the world. Otherwise, execute the world. Right, that makes perfect sense. And there's my end of my if statement. Okay, yeah. Let's run it one more time. Okay. I was going to draw the trail. You know, the lines. That's why I accumulated that trail. But now looking at it, I don't think that would be very interesting. Okay, so, you know, it's doing this 30 times a second, roughly. I don't know how many lines there are. And that's the end right there. Okay, that was the ending position. And we know we got the right position. So, okay, guys, that's the end of part 1. Now, that was a little better. A little more disciplined, huh? You know, I did my tests, right? I didn't go down too many rat holes. The rat holes I did go down were necessary. But you pair programmers really let me down. I mean, come on. You should have spotted almost, you know, all of those things that I did wrong right away. So, I'm mad at you guys now. Anyway, let's just fix that acceptance test. Go back to auto. Run the auto. Thank you. And that will tell me what my number was. My number was 1106, so we're going to stick that in the final acceptance test. And now the acceptance test should pass. All right, that's enough of that. I got to go fly. I got to practice a bunch of approaches. Maybe I'll see you tomorrow. I'm not sure. Bye. Man.